In this how-to video, we will show you how to install, set up, and run a CJWinter 191ER attachment on a Hardinge Talent 51 MSY machine to produce a half 20 thread. We will start with blank preparation. This is the most important part of the setup for thread rolling. Poor blank preparation, design, or inconsistent blank preparation lead to a poor finished part, and no amount of adjustment to the thread rolling head can correct that. Here are a few guidelines to follow when preparing a blank. We will begin with preparing the blank diameter. The recommended blank diameter is listed in the data reference sheets. Use this as a starting point. You can see here we're rolling out a half 20 thread and it's a 50 thousandths pitch. You can see the min and max pitch diameter as well as the recommended starting blank diameter of 0.4655 inches. Look at the chamfer angle first. The leading and trailing edges of the blank should have a 30-degree flat chamfer leading up to the blank diameter on both sides of the part, on the inside and the outside. The chamfer will result in a 45-degree chamfer on the finished part. The chamfer will also help with feeding and alleviates unsupported side pressure on the first engaging tooth of the thread roll die. Unsupported side pressure on the first tooth is the leading cause of premature failure. Determine the length of the thread blank. The blank length varies with the desired thread length, material, and the configuration of your part. As a general rule of thumb, the first and last full threads will occur between half and 1 full pitch inside the ends of the blank. Material quality, seaming, tubing, bars, voids, hard spots, inconsistent chemical makeup, inconsistent and non-symmetric grain are all problems when rolling parts. Rolling threads on a poor material can result in threads with cracks, flaking, uneven threads, elongated threads, thread rolling die breakage, and reduced thread roll life, among other problems. Purchasing a higher quality material will not only improve the performance of the thread rolling process, but will add productivity on almost all stations of your machine. The increased cost of high quality, consistent material is always offset by greater tool life, easier setup, less downtime, and less inspected parts. Operation and installation of the attachment. With the exception of the thread rolls, the CJWinter end rolling attachment will be shipped with everything you need to install, set up, and operate. For the installation of the thread rolls, it is critical that they are on center so that the finished product is within half a thou TIR. Assembly order for the attachment. Put the attachment on a flat surface. Remove the 3 screws that secure the front plate as well as the front plate itself. From the attachment, assemble the rolls over the carbide bushings in a clockwise direction with either 1, 2, 3 or ABC facing upwards. Then replace the front plate and tighten down the button head cap screws. We'll set the head for the minor diameter of the thread. Look up the minor diameter on the data reference sheet corresponding your thread rolling attachment. In this case, the minor diameter is 0.4387 inches for the half 20 thread we're rolling. Using the bolts to allow the head to be adjusted freely. Pull the shank to pull the attachment into the open position. The head will rotate to the right if you're looking at it from the front. Where the gauge is inserted, insert the gauge or part into the attachment and then turn the shank in the opposite direction to set the minor diameter. For the gauge or part's standard attachment, tighten down the bolts. This will lock it into place and ensure no movement of the head. Once its position is set, you may remove the gauge. We want to make sure the attachment is on center, so we'll load our gauge pin into the attachment. And using a centering type of indicator, make sure that the attachment is properly centered within 1 thou and a half. As you can see from the indicator, this one's on center within a couple of tenths, and that's very good if you can shoot for that. Setting the thread length. This is done with the attachment in the open position. Advance the attachment over the part until the thread length that is required is achieved. Verify any clearance issues and return the attachment. We set the attachment in the closed position off the part. Rolling speeds. Depending on the capabilities of the machine and the configuration of the part, this would be a recommendation for rolling speeds. For this particular size, we're going to be rolling 65 surface feet per minute, which is the equivalent of 500 RPM. You also need to check the feed rate. This is a half 20 part, the pitch being 50 thousandths per inch. Usually, we reduce this feed rate by about 3/10, resulting in a final feed rate of approximately 0.497 inches per revolution. We are now going to talk about maintenance of the attachment. Regular cleaning is very important. In between jobs and during tooling changes, disassemble the major components of the head and clean any accumulation of chips or debris. Pay particular attention to the clutch plate, retaining blocks, carbide bushing, and eccentric pins. Verify that they are clear of any form of materials, and move and rest without issue. Now, we are going to talk about lubrication of the attachment. Lubricate all surfaces and moving components with a full synthetic oil, such as Mobil 1 oil. This oil has been recommended because of the superior film strength and lubricity. Use of other oils may result in the galling of components under the working loads of thread rolling. Check the attachment for wear. Areas to pay particular attention to are the eccentric carbide bushings and internal wear surfaces. Make sure there are no high spots or galling on the surface where the carbide bushing is located upon. Check the drive pin and the base of the pin where it meets the retaining block for the same conditions. If there are any signs of wear, the pin should be replaced. On the front plate and cover plate, make sure that the locating holes for the eccentric pins show no signs of wear or change of fitment. If this has happened, replace the worn out part. Now, we will cover the shaft spring housing. Inspect the coupling and make sure the surfaces are not worn. Ensure the shaft moves freely when disengaged. If the surfaces are worn on the attachment and the attachment does not open freely, replace the cover plate. Now, we will install the optional lockup plate to the attachment. Make sure there is no movement of the shank and the cover plate when the lockup plate is installed. You might have to adjust the height of the counterbore on the lockup plate to achieve this. Reinstall the flat washer and then install the 3 retaining bolts loosely into the attachment. Now we can set the minor diameter of the part. First, insert a gauge pin or part into the thread rolls. Make sure it fits snugly by rotating the attachment. Then, secure the 3 bolts located behind the attachment's head tightly. This particular head has the lockup plate installed, and now we are going to run it with the lockup plate. The biggest difference is the attachment won't spring open, but we also adjusted the feed rate to about 20 TPI, or about 50,000 inches per revolution. No compensation is needed on this one. The attachment will feed in to the set pitch depth, stop, reverse, and feed out.